In this video we will explain the basics about SDR. SDR means Software Defined Radio. In this type of radios, some tasks that in a common radio, in a hardware radio, are performed in hardware will be done in software. Not every task, but some of them. Good examples here are mixers, analog to digital converters, digital to analog, filters, etc. This approach implies a reconfigurable radio, the same hardware but different software to do different things at different times. Here we have 4 examples. The first one could be with my software-defined radio, but the software could be a GSM BTS. Another example with the same hardware, it's implementing a satellite receiver. The third example, it's a plane tracker. And the fourth example, it's an FM demodulator. The typical SDR blocks, this is the components of a software-defined radio, are the following. The RF conversion stage, where the signal is amplified and converted to intermediate frequency. The analog to digital or digital to analog conversion, where you will convert the signal from analog to digital in case you are in the receiver, or digital to analog in case you are in the transmitter. The next stage is the intermediate frequency processing stage. Here we will convert the signal from the intermediate frequency to baseband. In the baseband processing, a lot of tasks are performed, for example, modulation, synchronization, etc. And finally, in the last stage, where we have bits, the interleaving and other things over the stream of bits are performed. Of course, there are many different architectures for this approach, which is very flexible, but demands a lot from the hardware. The radio, the software radio, needs to work in different frequencies, which implies more capacity, which implies a complex software to control all these functions, to do all the modulations, the waveforms, and everything that we saw in previous videos. This philosophy has a lot of advantages. It's very easy to upgrade. It's very easy to reconfigure, to change some parameters. You don't need to remove a component and place another one on its side. It's very cheap to construct. It's multifunctional and also is very flexible. Now let's talk about the SDR history. This term surges back in 1992 and it was coined by Joseph Mottola. But there are devices available in the market since 1985. Now let's think about the future or the ideal SDR system. This ideal SDR system, it has only 2 stages plus the antenna. The first stage is the analog to digital and digital to analog converters, and the second stage is the baseband stage. So everything after the conversion is done on baseband. We can talk about 3 different phases in the evolution of the SDR technology. The first one, the early days, was used, for example, in GSM, the mobile communication systems of the 2nd generation. Here you have 3 different frequencies. The first one, the RF frequency, from the antenna to the first converter. The second one, it's the intermediate frequency, from the first frequency converter to the second one. And also, after that last conversion, the baseband. So you have 2 steps between the transmitted frequency and the baseband. It's very limited by the performance of the analog to digital and the digital to analog converters. In the second phase, which is the phase we are now in, the sampling and the digitalization of the signal starts in intermediate frequency. Also, this intermediate frequency is higher than in previous phases. This lets us to work on higher frequencies. It's more digital than the SDR first generation. You have an analog domain, and this analog domain, a part of it, it's on RF domain, and the second part is on intermediate frequencies. As we said, some of the processing starts on intermediate frequency. This conversion is done on intermediate frequency. And finally, we do all the baseband processing after the last frequency conversion. The third phase, which is still not available, it's the ideal one that I mentioned before. It will consist on a direct sampling over RF signals, so no intermediate frequency between them. It will be possible only when the ADC and DAC converters work at gigahertz. Now let's look at some good examples of SDR technology available in the market. The first one is the USRP radios by Etus. Etus is a company owned by National Instruments. These radios are FPGA based. They can work up to 6 GHz. Its price is, let's say, low range, but are a very good product and very cost efficient. They are also available in many different series, depending on the profile on the application that you need. The Boost series, the Embedded one, the N and the X series. Another good example, very popular in the last months, is the HackRF1. It's a low-cost device, not as low as the RTL, but it's a transceiver. It not only receives as the RTL, but also transmits. It's half duplex. That means that when you transmit, you can't receive, and vice versa. And it can work in both standalone and PC peripheral mode. And this is. Thank you for your attention.